How's it going, guys? Today in this video, we're going to be doing over Module 12.2, Day 2, simplifying radical expressions, and we're really going to be practicing using all our properties of rational exponents. So on this page of your notes, you should be familiar with it. We've gone over it in the last video or in the last day of the notes, whichever you saw. But the only difference that we need to make here, only change we need to make, is on this first row, last column, it should be a to the m plus n like that. All right, so let's keep on going. Number one over here, we have 25 3/5 times 25 to the 7/5. So we have two powers with the same base. So if you have two powers with the same base, that means we can add the exponents together to get, or combine the two powers together. And to do that, all we do is add the exponents. All right, and that's going to be our product of power rule. So we get 25 3/5 plus 7/5 is 10/5. 10 over 5 reduces to 2. So we get 6/25. And for number 2, we're going to use our quotient of power property. We have a power on the top and a power at the bottom, or a power dividing another power. They have the same base. So what we're going to do is subtract the top exponent with the bottom exponent. So 1/3 minus 2/3. And that's going to give us 8 to the negative 1/3. If anytime you have a negative exponent, we're going to change it and take it to the bottom. That's how we change a negative exponent to a positive one. So we change 8 to the negative 1/3 over 1 to 1 all over 8 to the positive 1/3. You take the power and move it to the other side of the fraction. And you change the exponent from a positive to a negative. So now we have 1 all over 8 to the 1/3. And 8 to the 1/3, that's the cube root of 8. Right? Remember, exponents are power over root. So the third root of 8 is going to give us 2. And that's our answer. All right, for number 3, we have y to the 4/3 divided by 16y to the 2/3, all of that raised to the 3/2. So what we're going to do here is, or what I'm going to do is, I'm going to simplify everything inside the parentheses first. You could distribute out the 3/2 first, but that would be much harder. It's easier to simplify as much as you can and then distribute out that exponent. So inside of the parentheses, we have y to the 4/3 divided by 16y to the 2/3. That's all raised to the 3/2. And we see we have a base of y on the top and bottom of this fraction. And since we have the same base on the top and the bottom, we can use our quotient of powers property to combine the two into one base. So the top will become y to the 4/3 minus 2/3. We're taking this exponent and subtracting it with the top one. And we're left with 16 on the bottom, all raised to the 3/2. So the top, we get y to the 2/3, all over 16, raised to the 3/2. And now we can take this 3/2, and we can distribute it to the top and bottom using our power of a quotient property. So now we're going to distribute out that 3/2 to the top and the bottom. We get y to the 2/3, raised to the 3/2, all over 16 to the 3/2. So anytime you have a power raised to another power, that's our power of a power property. We can just rewrite this as y to the 6/6. You have a power to another power, you multiply them together, and you have your new exponent, or your new power. And on the bottom, we have 16 to the 3/2. That's the same thing as the square root of 16, all to the third power. Remember, the root of 2 is the same thing as the square root. They're the exact same thing. So if we solve this out, y to the 6/6, that's y. 6/6 is just 1, and y to the first is just y. The square root of 16 becomes 4, and 4 to the third power is 64. So that's number 1. or number 3 rather. On number 4, what we're going to do here is we're going to use our power of a product property again to distribute out the exponent to both parts of the product. So when we do that, we have 27 raised to the 2/3 times x to the 3/4 raised to the 2/3. So 27 to the 2/3, that's the same thing as the cube root of 27, all squared. And x to the 3/4 raised to the 2/3, that's another power to a power. So we get x to the 6/12. Power to a power, you multiply the exponents, and we get x to the 6/12. And if we keep reducing this down, the cube root of 27, that's going to give us 3. So we have 3 squared. And x to the 6/12, that reduces down to 1/2. 3 squared gives us 9. So we have 9x to the 1/2. And that's going to be our simplified answer for number 4. All right, so here we're talking about simplifying radical expressions using the properties of exponents. What that means, or what we're going to do, is we're going to take these radical expressions and we're going to change them into rational exponents or into terms with exponents in them, so we can actually simplify, add like terms, and ultimately simplify this as much as we can. So for number 1, that first x is just going to come down as an x. We can't really change it that much. For the cube root of 2y, we're going to change it to 2y to the 1/3. Right, it's the same thing, the power of 1 all to the root of 3. And for the cube root of 4x squared times y squared, we can change that into 4x squared, y squared all to the 3rd power. Or sorry, to the 1/3 power. And now we're going to take this 1/3 and distribute it out into each term in that parentheses, and we'll do the same thing with this 1/3 as well. So when we distribute it out, we have x times 2 to the 1/3 times y to the 1/3 times 4 to the 1/3 times x squared to the 1/3, and finally y squared to the 1/3 as well. So we're going to keep simplifying these down. The x will just be x to the 1/3, can't be simplified anymore. Same as y to the 1/3. For this 4 to the 1/3, what I'm going to do is I'm going to change 4 into 2 squared. And I'm going to do that because if I can change it into that form, I have 2 bases of 2's that I can add together. Or not add, but rather combine together. So 2 squared all raised to the 1/3 times x squared to the 1/3, you have a power to another power. So you get x to the 2/3. And same thing with the y squared, a power to a power. So we have the power of a power property, and we get y to the 2/3. So let's keep on going. Now we're going to add like terms. So with x, we have x to the 1st power and x to the 2/3. They're being multiplied together, so we can add like terms, or rather add the exponents together. Right? X to the 1st is the exact same thing as x to the 3/3. And we want to put it as 3/3 because the other term has a 3 in the denominator for its exponents. So we want to add the exponents together. We need to make sure the denominators are the same. So x to the 3/3 times x to the 2/3, that gives us x to the 5/3. You're multiplying 2 terms with the same base, so you add the exponents together. So these go away. Next, we have the 2's. So you have 2 to the 1/3 and 2 squared to the 1/3 as well. So that 2 squared to the 1/3, we can actually rewrite that as 2 to the 2/3. Because we have a power to a power, so 2 squared to the 1/3 will give us 2 raised to the 2/3. So now we can multiply these two together. We have 2 to the 1/3 times 2 to the 2/3. They have the same base, so we'll add the exponents. So we have 2 raised to the 3/3. And lastly, we have y to the 1/3 and y to the 2/3. They have the same base. We're multiplying them together. So we just add the exponents. So we get y to the 3/3. So if we rewrite this, we're just going to get 2 to the 3/3 is just 2 times x to the 5/3 times y. Y to the 3/3 is just y to the first, which is just y. And that would be our simplified answer for number 1. And now for number 2, I'm going to do it down below here, just because you don't have any room up top. Number 2, we have 64y, or the square root of 64y, all over the cube root of 64y. So we have two radical expressions, and we're going to rewrite them as rational exponents so we can reduce this and simplify it down. So 64y becomes 64y to the 1/2. And the bottom, we get 64y raised to the 1/3. So we have the same term of 64y on the top and bottom. So that means we can just use our power of quotient property, and we can combine the two terms. Or sorry, quotient of a power property. So we get 64y raised to the 1/2 minus 1/3. Right, top exponent minus bottom exponent. And 1/2 minus 1/3 is 1/6. So we get 64y raised to the 1/6. And then from here, we're going to take this 1/6 and distribute it out to each term inside the parentheses. So we get 64 to the 1/6 times y to the 1/6. And we can rewrite the 64 to the 1/6 as the 6th root of 64 multiplied by the 6th root of y. And the 6th root of 64 is going to give us 2. 2 to the 6th power gives us 64. So we have 2 times the 6th root of y. And that's our simplified answer for number 2. All right, for number 3, same thing. We have a radical expression. We're going to rewrite it as a rational exponent and simplify it down as much as we can. So remember, the exponents are power over root. So on the first one, we have a power of 3, or on the top rather, power of 3 and a root of 2. And the bottom has a power of 2 and a root of 3. So we have x to the 3/2 divided by x to the 2/3. We have the same base on top and bottom. So we're going to subtract the top exponent with the bottom one. So the x to the 3/2 minus 2/3. If you solve that out, you should get x to the 5/6. You're just subtracting fractions. Now for number 4, same thing. We have 3 radical expressions. We're going to change them into rational exponents and simplify it down. So the first one becomes 16 to the 3/6. Then we get 4 to the 6/4, and then 8 to the 2/3. 16 to the 3/6 is 16 to the 1/2. 4 to the 6/4 to the 6/4 is 3/2. And 8 to the 2/3 is just going to be 8 to the 2/3. So the square root of 16 times the square root of 4 raised to the 3rd power times the 3rd root of 8 all squared. We're just changing the form back to a radical expression so we can simplify it out from here. And what we can do here is we see the square root of 16 gives us 4. The square root of 4 is 2, so you have 2 cubed. And the cube root of 8 is 2, all squared. So what we see here is that we can solve this all out normally, just multiply it all together, or we can see that 4 is the same thing as 2 squared. So we get 2 squared times 2 to the 3rd times 2 squared. And we have the same base for each of these terms. So we just add all the exponents. So we get 2 to the 7th, which gives us 1/28. So let's keep on going. Now we're going to talk about 2 new properties. which are very similar to properties we already know, but these are going to be in the form of roots. So the product property of roots, that says if we have, say, the cube root of 16, we can rewrite it as the product of cube roots that multiply out to 16. So in this case, 8 and 2 multiply to 16. So we can rewrite the cube root of 16 as the cube root of 8 times the cube root of 2. Or in algebraic terms, the nth root of a times b will equal the nth root of a times the nth root of b. And for the quotient property roots, that's just saying if we have a square root of a quotient or really a fraction, we can distribute the square root, or the radical rather, to the top and the bottom. And in a case like this example here, we see that it helps us solve it much easier. Or in algebraic terms, the nth root of a over b will equal the nth root of a divided by the nth root of b. So let's actually look at some examples here. So on number 1, we have the cube root of 256 x cubed y to the 7th. So the first thing I'm going to do is rewrite 256 as 2 to the 8th power. It's the same thing, but it'll help me reduce it later on in the problem. That times x cubed times y to the 7th. And what I want to do now is I'm going to separate this radical expression into 2 different radical expressions. One that can be that we actually take the cube root of, and the other one which will be more of our remainders. So I can rewrite this as the cube root of 2 to the 6th times x cubed times y to the 6th. And that's all going to be multiplied by everything that's left over, 2 squared times y. So when I multiply these all back together, I'll end up with what I started with. And the reason why I split it up this way is because this radical expression here can reduce down evenly. The cube root of 2 to the 6th is going to be 2 squared. The cube root of x cubed will just be x, and the cube root of y to the 6th is y squared. And it's all being multiplied by the cube root of 2 squared, which is just 4 times y. So we get 4xy squared times the cube root of 4y. Let's write this a little clearer. 4xy squared multiplied by the cube root of 4y. And that's our simplified expression for number 1. For number 2, we're going to use our quotient property of roots. So we can distribute out this 4th root to the top and the bottom. So the 4th root of 81 on the top, divided by the 4th root of x on the bottom. The 4th root of 81, that's going to be 3. And the bottom, we can just rewrite it as x to the 1/4. So the only problem with this here is that we don't want to have any radicals on the denominator of a fraction. And if we don't want any radicals, that means we don't want any exponents that are in the form of a fraction. So we cannot have x to the 1/4 on the bottom. So what we're going to do is we're going to multiply it with some base x, so we'll actually add with the other x, to change that 1/4 to a 1. And remember, if you're multiplying 2 terms with the same base, you add the exponents. So we need to look for something that adds to 1/4 that gives us 1. And that's going to be 3 over 4. And what we multiply with the bottom with, we multiply the top with as well. So we end up getting 3 times x to the 3 over 4, all over x to the 1/4 times x to the 3 over 4. And that's why we're multiplying by x to the 3 over 4 and not say x to the 4th, because when we multiply these 2 terms together, we're actually adding the exponents. So we end up getting 3x to the 3 over 4, all over x to the 4 over 4, or just x. And that right there will be our simplified problem for number 2. So we have one word problem we want to go through rather quickly. So here we're told when we find or apply a function model involving rational powers or radicals, you can use the properties in this lesson to help you find a simpler expression for the model. So for instance, on this example here, we have this expression here, s equals 6 pi times b over 2 pi raised to the 2/3, and that gives us our surface area of a can in terms of its volume. So what we're going to do is take this expression, s equals 6 pi, multiply by v all over 2 pi, raised to the 2/3, and we're going to simplify it down as much as we can. And the problem also tells us to write an approximate model with a coefficient rounded to the nearest 100. So that's what we're going to do. So first thing I'm going to do is take that 2/3 and distribute it to the top and to the bottom. So I end up getting 6 pi times b to the 2/3 all over 2 pi all to the 2/3. And then for the top, I'm going to rewrite it as 3 times 2 pi times b to the 2/3 all over 2 pi raised to the 2/3. And the reason why I broke up the top like that is so I have the same base of 2 pi on top and bottom. So from here, I have the same base on top and bottom, so I can subtract the top base by the bottom one. So the top has an exponent of just 1, which is the same thing as 3 over 3. So I end up getting 3 times 2 pi to the 1/3 times v to the 2/3, and the bottom goes away since we subtracted it with the top exponent to get us the 2 pi to the 1/3. And the last thing we have to do is figure out a coefficient. So we're going to plug in that 3 times 2 pi to the 1/3 into a calculator and round it to the nearest 100. And when you do, you're going to get approximately 5.54 times v to 2/3. So that's what our answer for part A is going to be. Approximately, let's actually write this properly. S will be approximately 5.54 v raised to the 2/3. And for B, we're told to graph the model using a graphic calculator. We're not going to do that. And we're asked, what is the surface area in square centimeters for a can with a volume of 440 centimeters cubed? So it wants us to figure out what S is going to be when V is 440. So you have S equals 5.54 times 440 raised to the 2/3. We just plug in 440 for V. We're going to solve this out. You can put this all into your calculator to solve it out. And when you do, you're going to get approximately 320. So that's the video, guys. It is a lot of material. But hopefully it helped. But before I actually end the video, I do want to show this in case it's not on Canvas. But these are some extra problems to help you fully understand the material. If you haven't taken the 12.1, 12.2 quiz yet, being able to solve all these problems will mean you're in a pretty good position to do well in the quiz. So I would pause the video, take a picture of it, screenshot, whatever you want to do, write them down, but be sure to actually work these problems out and make sure you can actually solve these out so you'll be in a good position for the quiz.